Good morning. Happy Sunday. Actually, it's the afternoon, so have a happy afternoon too. What's up, everybody? I'm Greg from Greg's Tutoring NYC. Coming at ya! Smash the like button, please. Hopefully, you guys are enjoying these. I'm getting some nice compliments in comments and in emails. I appreciate that. I appreciate you appreciating me. Smash the like button, subscribe. There's more to come. Hopefully, this is the last part of this. It's 10 parts. It took a lot of effort. And I have one more question after this, if we can get through the stream. The last one disconnected on us. So I'm going to start right there. So let me get rid of this thingy here. The last thing we were talking about was the question underneath this here, which was dealing with knowing your formulas. That's an important thing you guys got to do. Math is not about memorization, but there's parts that you need to memorize. So there you go. So what we're doing is we're exploring what I'm calling the hardest math problems from grade 3 all the way to grade 8. We're basically on the last set of multiple choice ones. I actually have a whole nother set for all the grades that show you work ones. So I don't know if I'm going to get to do that anytime in the near future, if ever at all, but that's something on the horizon that we can do as well. So I'm not just doing multiple choice questions. We'll start from grade 3 to go to grade 8 using the same thing. My sourcing here is the New York State exams, which is semi-equivalent to a lot of states. So this is not just New York specific we're doing here. And the goal is to see why people are having problems with certain math questions. It's not to game a test. It's not even to do a test. Although that said, a lot of these can be used as a stepping stone into taking a test. All right. My mic just broke a second ago, so I hope I'm coming through here. Actually, let me test this out because I don't want to be talking into dead air. It's not to game a test. Okay, beautiful. I sound lovely. All right, so let me get rid of this too. So we were doing the last problem there. And by the way, I showed that just as a reminder again, because we go all the way back to grade 3 and also including grade 4, grade 5, grade 6, grade 7, grade 8. When I started these, I show those in the beginning, and they kind of get lost in the muddle that you need to kind of know what's going on. So this question again, they showed a pyramid with a square base. Okay, so they're calling it a square. Whoops, let me turn on my tablet. I forgot about that with my earbud breaking. Hopefully the tablet's off or it does not crash. Okay, where we go. Let me see if I can write. Why is it not letting me write? Come on, guys. Okay, there we go. All right, so we had a square right pyramid that was being sliced by this gray plane and basically split in congruent solid shapes, right? This is a 3D shape. And then we were talking about that if we looked at it from this angle here, where the slice was, we would end up at this figure. And what we would see facing us is that red triangle, okay? So give yourself a few minutes to do that kind of cognitive transformation in your head of the visual, right? Okay. And even if you need to, get hold of a pyramid and kind of look at it, and you'll see, even without it being sliced, you'll be looking at that front face of the pyramid, which is slanted. It will be a triangle. So it makes sense that if you cut into it, right, if you're facing it where that green or red line are pointing at, that it would look like that red triangle if you were looking straight onto it. Okay. So then it says, now if we get to the question, the pyramid is sliced by a plane that passes vertically through the top vertex, which is up here. Okay, that's the vertex where all the edges inside meets at this top there. On a mountain, we would call that an apex, right? And it's perpendicular to the base. So that's what's happening. That if we were to extend the base, right? Because if we cut it in half, each base was 2 by 2. So this would be 2. This would be the other 2 from the face, the bottom of the part we came out. The back would be 4, right? And I did that kind of sloppy. but the front here would also be 4. Okay? And I'm not showing the top of the piece that's missing. I'm only showing the bottom of it. Okay? And again, I drew that sloppy. Let me try that again in purple. So if I did this, 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 that would be the base of the bottom. Okay? So what they're saying is that red thing, if we were to draw a line of center on it, right, it would be perpendicular to the bottom on both sides. In other words, it would be standing straight up from the base. Okay, that's all that's saying there. Okay, then it says, what is the resulting 2D shape? Okay, so what I was showing you yesterday was the 3D formulas for volume and stuff like that. A 2D shape means area, not volume, so there's 2 dimensions to it. So we're left with the triangle, right? So the area of a triangle, well, let me shift this up again so we can start seeing the answers. So since it was a triangle, we had ruled out C and D, if I remember. Let me let this scroll first. Because even though the base is a square, which is also a rectangle, it's not asking for that 2D shape. The gray thing slices the base in half. It doesn't slice through the base. Okay, so C and D are not valid choices. So we know that the area, let me just get this last choice showing. The area of a triangle, right? We can do that over here. Of a triangle is 1/2 BH. So again, know your formulas or you can't solve this. There's no way to solve it if you don't know your formulas. Okay, because we got through the conceptual part of this now. Now they're asking us for something specific. Okay, the base is the bottom, right? So the bottom across here, as we just said over before, is 4. So we're talking about 1/2 that's a lousy 2 times 4, and the height stays the same. That 10 is not the height of the slanted thing, it's the height from the apex straight down perpendicular to the bottom. So the height is 10. So no matter how do you slice this, you get 1/2 times 4 times 10, and you end up getting 20. I know my handwriting is atrocious there, so the answer here would be A. Okay. What I want to do too for 1 second is to go back to one of the other examples, because while I was loading this to do the stream, it brought that page up for me first, and I noticed I made a mistake. Plus, I cop out on doing the multi-digit arithmetic on a lot of these examples, just because the software and stuff is kind of sloppy-ish and so on. So we had, where's the question? That wasn't the question. Because I noticed I did a righto while doing it. Let me see if I can find that. I think it was 3 or 4 before this one. Okay, here we go. It was this one here. So it was the cylinder one here. First of all, I correctly, whoops, too far. Come back. Okay, so here, what I want to do is actually do the computation for you guys, just to kind of see what it was. So there is another kind of level to this, which is that if we had to subtract the 2 things, we have 32 pi whoops, I wrote that wrong. I was ready to write pi. So let's do this. I'm going to write on top of it. 32 pi minus, and I had estimated it to be about 0.9 down here. But if we just do the 2.8 over 3, let's just keep it that way, Because what I'm going to do is I'm going to bring up my calculator and actually show the computation for real. Okay, but there's something here you should notice, which sometimes helps your computations be easier, sometimes not. This is the distributive property. This is pi times 32, and then pi times 2.0/3. So what we can get is pi times that's a parenthesis 32 minus the 2.8/3. Okay, that's an ugly number. We know it's 0.9 something. But if it was like 2.7, this would have been an easier way to do it. Okay. And with the calculator, it still isn't too bad. So the reason I'm kind of showing this is, if you remember the answer choices, it's asking us to compute the answer to the nearest 10th. Let me try to scroll that up. And we estimated the answer was the 97.6, if I remember right. One more second. Let me just make sure those are on the screen, because what I just wrote is going to scroll off. All right, I can scroll up just a smidgen more to at least get that choice back in there. Okay, so the answer turned out to be C, and we figured it out by estimating. And I told you guys basically, oh, do it yourself. Don't depend on me, right? That kind of a thing. So let me bring the calculator up and actually do that computation. All right, you guys should see the calculator now on your screen. So what I'm going to do is the 2.8/3 first. 2.8 divided by 3 equals this 0.9 repeating 3 thing. So what I'm going to do is subtract 32 from that, because I have a dumb calculator. I don't have an intelligent calculator where I can't, this has no memory. It doesn't have scientific notation. So I can't store the value 32 and subtract this from it. So what I'm going to do is the opposite way. Okay, I'm going to subtract 32 from this. Okay, and that gives us minus 31.06. So that's more or less this estimate here that we made, where I said 32 minus about 0.9 is about 31. So we can see on the calculator that it's exactly 31.06666666. Repeating 6. It's 31.0 repeating 6. Okay? So all we have to do now is multiply that by pi, because that's what this is saying up here. Okay? Right? That's the last thing I just drew right here. Okay? Now, I originally said, when I wrote yesterday too, the 3.14 is usually not enough. Okay? So what I'm going to do is multiply that by 3.14159. And I'm going to get a negative answer, but because I flipped the subtraction, whatever answer I get, the positive, the absolute value of it, will be the answer. All right? So I'm going to multiply that by 3.14159, just to make it more accurate. And I get minus 97.59, and as you could see, that's 97 point, it rounds to 97.6. So what I'm going to do is I'm going to do it a second time. So that's the way we can prove the answer is there. And again, if you're in a no calculator test, you have to do this by hand. There's no other way to do it. But just to let you show that that if we didn't use 3.14959, the answer could be off by a lot depending on the answer choices. So I'm going to do this whole thing over again to get that. So I get 2.8 divided by 3 equals that thingy. I'm going to subtract 32 from that. Okay, and I get back my minus 31.06 bar. Okay, I'm going to multiply that by just 3.14. Okay, look what I get. I have like a whole couple of hundreds off. So instead of if we were to round this, we would get minus 97.5. Okay, it doesn't quite meet the 97.6 thing here. So in this example, there was no other choice near there. So even if you happen to use the 3.14, you wouldn't have been led astray. But I'm just showing this to you guys to let you see that there's a margin of error if you don't use enough decimal places for some of these. Now, most of you are not going to type in 3.14 or even 3.149, okay, because your calculator has a pi key. But the calculator you see on the screen here doesn't have a pi key. All right? Okay, so let me go back to the other question because I think, was that the last one we did on this side? Let me see here. By the way, I think I misspoke slightly in this one. I was saying as we were looking for the choices that we were looking for times 15, but it says twice the rate, so we should have been looking for 30 times 30, all right? So just for any clarity of that. I think I said it, but I also contradicted myself as I was going. There's an issue. Anybody you see live streaming, especially with math, in anything that lasts an hour, they're definitely going to make a mistake in their statements, okay? And I do it. On top of that, I have dyslexia and a whole bunch of other stuff. So that's something that you guys need to be aware of so we can catch stuff like that. All right, so let's continue on. I think that's the next one, but let me make sure. Yes, it was. Went too far. Again, if anybody has questions, please ask them. If you're catching on this a replay, you can pause. If you're catching this on the replay, you can still smash the like button. Imagine that. Okay, so I think this one is kids got wrong for two reasons. One may have been the math. The other was the way the question was worded. Because a lot of kids, again, this is a question that hundreds of thousands of kids took, and the majority of kids got it wrong. Like 80% got it wrong. Okay, so let's just look at the figure. So we have this letter M inscribed on the coordinate geometry grid, right? Just maybe one more second to make sure we're live. Yes, we are. I see a few viewers out there. Hello! Please like and subscribe. Why are you watching and not subscribing, not liking, not commenting, not just jumping up and down for joy? Okay? All right, anyway, back to the problem. So we're going to focus on the illustration. We have an x and a y coordinate. Cool. They're by units of 1, 2, 3, 4, 1, 2, 3, 4, yada, yada. We have this M shape. So I don't know what else is going on there. I don't know what they want us to look for here. So a function of x, okay? So in a function, whoops, of x, okay, is shown here. So the all those lines of the function. So this is a case where we may have equals, and then often it's a curly brace with something in it, followed by another curly brace. So this is a function that works in steps. The part here, I'll label these. We have A, I'm labeling the lines. B, C, and line D. Okay, and this is called a stepwise function. So some functions we have like a line, or we can do a circle or a parabola. Some are actually split into sub-pieces. Okay, no reason it can't be. Okay, so now the question is, over which interval is the function increasing? Okay, so clearly it's only increasing over A, and it's only increasing over B. Okay, I mean, sorry, C. So let me do that in red. So it's increasing here, and it's increasing here. Okay, that's the only two places that it increases. All right. Let me scroll this further. so we can actually see the answer choices. Let me move this over more. Come on. Okay, so when it's saying over which intervals, it's talking about x. This means for what values of x. This is coded language. That means for what values of x. Because if you want, instead of the f of x over here, you know, especially with the equation of a line, we can say y here. So it doesn't really matter the symbolic notation we're using. It's the semantics, the meaning they're using. So don't get bogged down with syntax and words. So we have each thing is separated by 2. So we're going to do a true and false table. So from -4 to 2, it's increasing. Yes, it is. Okay. And then from -1 to 1, right, over here, it's going to go and make this kind of V shape. Okay. So I think this is the error some kids made, that because this part right here is increasing, they just assumed, okay, cool, even though it goes down, it still goes up. But that's not what the question means. It means only increasing, right? Stick in there the word only. Over which values of y is the function only increasing. So for that reason, this is false. So that's no good. -2 to 0, no, that's false. 2 to 4, and once we get a false, we can stop. But I'm just going to do this for completion. From 2 to 4 is also false because it goes down. That's D, right? And B says -4 to -2, it's increasing. That's A. And 0 to 2, it's increasing. Yes, that's C. So that's true. So the answer there would be B. And let's just be sure. -2 to -1, nope, that's false. And 2 to 4, nope, that's false as well. All right, so that's the deal with that. And the good kind of thing is this: once you understand the language, this is really a 15-second problem. It's not complicated. It's not hard. Okay, now I could see why this throws off a lot of kids. So first of all, some of you don't know the system of equations at all. It's just basically 2 equations. If you notice, there's an x and a y. So this is one way of writing the form of a line, right? We can contort like the 3x plus 4y into y equals something, right? It would be y equals 5/4 minus 3/4. Okay? I did that in my head. I may have said it wrong, but it's not important to this problem. So it says, which set of equations has no solution? So we can kind of plot these out and do a whole bunch of gymnastics and a whole bunch of stuff. But what we need to do is, once we understand what a function is and what a system of equations is, we can use what we know. Okay? It turns out that both choices in A is the same line. It's the same line. It's the same line on top of itself. Okay? We know that because if we multiply the whole top of A by the number 2, right? Do the distributive property, right? What we do to the left side, we do to the right side. So if we multiply every term by 2, we're getting the exact same equation out. So 3x times 2 is 6x, 4y times 2 is 8y, and 5 times 2 is 10. Okay? So a systems of equation means that all points on both of these lines are the same because it's the same line. Okay? We have something with C. C looks weird. However, and by the way, if we go back to A, we could have divided the second thing, the 6x plus 8y equals 10, by a half and gotten the first equation. So we have a yin-yang going on between these two, that it doesn't matter which one we pick. If we multiply the top by -1, we get the bottom. Talking about C now. If we multiply the bottom by -1, we get the top, right? So we're going to do the same kind of thing, that if we took the whole first equation and multiplied it by -1, so 2x times -1, we're going to run the distributive property again on the whole equation. What we do on the left side, we do on the right side. We get -2x for that. Minus y times -1 is plus y. and minus 11. So this also is the same equation. So it turns out all points on both of these are all the solutions, okay? Because they're the same line on top of itself, all right? It turns out now this is the same line with something weird going on here. So because these are different, it has no solution. So that's why the answer here is that, okay? And for D, we could actually do the two techniques for solving a simultaneous equation. And we could have done this for all of them, which is substitution. There should have been a 1 in there. Sub. And the other technique is comparing one to the other. Okay. For instance, I could have multiplied the bottom by 3, and I would have got 3x. I'm talking about the second thing here. Plus 3y equals 0. Because 0 times 3 is 0. And then what I could have done was taken the first equation and subtracted it from this new equation. So 3x minus 3x is 0, so that term just goes away. 6y minus 3y is 3y. And then 1 minus 0 is 1. And therefore y equals a third. Once you get y equals a third, you can plug it into both of these. If y is a third, if we use the second equation, then x should be minus a third. Okay? And we can plug that in here. So minus a third plus a third is 0. If we plug it into 3x, we get minus a third. So we get minus 1 for this part, plus 2 equals 1. So that would work on both of them. So we can prove it kind of that way. All right, so let's go back to the beginning of the next line because we're done with that. We only have about 3 more examples. What I'm going to do is go back to an example I skipped because it's a little complicated-y. And do one last part 11 because we seem to be going good here. In fact, let me check that in 1 second to make sure the stream is still live. Okay, that's that. Okay, so we have another coordinate grid. Yay. I'm just going to read the, actually that fits. Okay, so we're good. So we have a line down here, right? And we don't know where this is going. It's a regular coordinate grid. There's an x and a y. We have no title to this. Everything is moving by units of 1. We know we have a positive slope. We know the y-intersection is minus 4, okay? And we could see if we went out to here that the x-intersection was probably 7, but we don't know if we need to care about that. Normally, we only need to focus on what's on the screen. Nothing is going on the top. It's just on the bottom, okay? And on examples like this, as we saw on many of the examples, they're going to end up trying to compare two things. So there's nothing else going on visually on the illustration. So let's try to look at the words. A line is graphed on the coordinate plane below. So I'm going to actually scroll this completely so that we get the top missing. So we can start seeing the answers. Okay, so it says the line y equals minus x plus 2 will be graphed. So that is not the line that's on here now. There's going to be a second line on there. So do we graph it? Perhaps we could. Let's see what the question is. So line y equals minus x plus 2 will be graphed on the same coordinate plane. So it's going to go on that same thing we're seeing above to create a system of equations. So as with the other example and all the other system of equation examples we've done and that you should have done in school, it's talking about where two lines are going to intersect. Where they intersect is where the solution of the system's equation is, okay? All right? And if you weren't sure of that, you can go back to the previous question I just did and try to match where I was going from that, right? There's a lot of math insights you guys are supposed to know. So there's two things. We could actually graph this line if we wanted to, and that could be tedious perhaps, because it's an intersection, what I'm going to do is my choice of solution here, because I think the other choices might be valid, is I'm going to see which of the choices here is on the line that they drew. Okay, so -2, 4, -2, 4 is over here. So that's no good. It's not an intersection point because it's not on the line they drew. 0 -4 is right here. So B is a candidate. C is 2 -4. That's over here. So that's no good. Okay. And D is 4, 2, which is right here. Okay. So now that I have the two candidate points, B and D, I'm going to plug them into the original equation. So if X is 0 on B, Y should be 2, but it's 4. So that means B is out. Okay. And now if I plug D into that, if X is 4, I get -4 plus 2, and therefore Y is -2. Bingo, we got it. Okay. So there's a lot of stuff happening in this problem, and it's pretty straightforward. It does make you brute force, basically. Actually, it's not brute force because we're using this strategically, knowing what's going on here. We're not making wild guesses. We could have plotted the line. We know that the y-intercept is here, and we just showed that that was one of the points. So the line there, if we took care to do it, is something like that. Okay, if you want to do as an exercise, you can certainly do that. In fact, that is the line, because if y is 0, x should be 2, and that's basically what I just drew, that line there. You could make it a little smoother than that, but that's basically what's going on there. Okay, so you could have plotted out, you could have done the plots for this and noticed where it intersected, and then got the system of equation solution by that. You could have also lined this up. You could also taken this equation here. Let's call this E or F. We could have taken equation F. We also could have taken this line here. And let's call this equation G. And we could have computed the equation of its line and then compared the two equations, just like I did with the system of simultaneous equations, that very last example where I subtracted to do from other, or I did the substitution. That seems like a longer way to do these. However, there are ways to double check your answer and make sure it's correct. Yay! Okay? Okay, this might be the last question. I'm not sure. No, it looks like there's still another page after this. Okay, which proportional relationship has the greatest rate of change? Oi, so rate of change is the slope. So that's, for that one, it's 7. Okay, it's proportional because there's a constant of proportionality. If x is 1, y is 7. If x is 2, y is 14. It's in perfect proportion. That's what proportion is about. It's about ratios. Okay, and basically it means 1x here. Sorry, 1y when we're doing that. So we can set this up to be something like that. Okay. So what we need to do is analyze each example they give here and basically figure out its rate of change. The slope is the rise over the run. So we need to figure out the difference between those, okay? So what we would have here is there's 8 is the difference of y, right? And the difference of the x is 2. So that implies that our slope here, and let's check, here it's 8, and here it's 2, and here it's 8, and here it's 2. So it definitely works. So our slope is equal to 4. Okay. And as you can see, our equation is just y equals 4x. We don't even need to do that, but just for completion purposes, we can actually do it if we want. Okay, and there's no b. We know that because this starts at the origin. So far, between 7 and 4, it says which has the greatest rate of change. It's A. A's the winner so far. So C, we computed C, but C, it's not helping us. A is the choice so far. Okay, B says the value of Y increases 12 for every increase of 4 in the value of X. Okay, so that means the ratio is 12 to 4 or 3, right? So it ain't B either, okay? So we ruled out C and we ruled out B, right? In other words, the equation for this one, for B, was Y equals 3x. Actually, did I say that backwards? Let's write it out and let's prove it. So it says the value of Y increases by 12 for every increase of 4. Right, so if X is 1, Y is 12. Is it X is 2? Y is 6. So I may have done that backwards. We're still getting the 3 though, so we're good. Let me scroll this off so we can get whatever D is trying to show us. 1 second. Come on, let's go the opposite way. And for D, we can actually just visually check it. If Y is 1, right here, X is 6. So if Y is 2, this should be 12. Okay, so basically for this one, we have Y equals 6x. So that doesn't work as well. And it also works from the coordinate 0, 0. So we're not going to get anything for that either. Why is this not writing that? It's not letting me write a 6. Okay. Let me drink something because my throat is going out. Okay, 30 gives us function P in our illustration. Y equals 7x plus 9. They give us an input-output function table. They're calling that function M with something going on there. It starts out by telling us that M linear functions, M and P. So this is also a linear function. They're both linear. Okay, so let's try to figure out the slope because I'm noticing it's asking us about the rate of change again. So we have 10 difference here, right? And a difference of 2 there. Okay. So it seems to me our slope is 5. Okay. We don't care about the y-intercept. Let's just double check that. That's 10 and that's 2. Also, even this one here, that's 10 and that's 2. And it works the same way. We're subtracting. We're always starting from this coordinate and then going back down to that one, right? So we're not switching. So we're doing between these two, and between these two. We're not flipping stuff backwards in different ways so that we don't, one case we get 5 and the other case we get -5. No, we're staying consistent in the way we did each point versus the other point. Okay, so we have 5 versus 7. So what actually is it asking us about the rate of change? Which statement is true? The rate of change differs by 2. 5 minus 7 is 2, yes. Let's just make sure the rate of change differs by 4. No. Function M has a greater rate of change. 5 is not greater than 9, so no. M and P have the same rate of change. No, 5 is not the same as 7. All right. So if you notice, they're honing in on certain ways of looking at problems and just doing specific stuff. So this problem kills a lot of kids. The whole transformation thing mind blows people. So often when you see a shape just sitting out here, like real cool, it's probably going to ask us to dilate this or move it or reflect it or rotate it or something like that, almost always. So let's just start with the normal. We're going to look at the visual. X-axis, Y-axis, nothing normal there, abnormal rather. The axis is both by units of 1, 1, 2, 3, 5, 6, 7, 8. There's a triangle there, ABC, okay? And we don't know what they're going to ask us, so let's peek at the question here. Triangle ABC is graphed on a coordinate plane as shown below. So let me scroll this so I can get the triangle still on the screen and perhaps some of the question. All right. I'm not sure if it's throwing the top triangle off for you guys. Let me see if I can figure that out. Yeah, I think the triangle's completely gone. So let's just deal with this for now. Let's see what the question is. So triangle ABC is dilated by a factor of 2. So the triangle is made twice as large. Okay? And not, this might have been an area question or a perimeter question as well. It turned out to be about dilation. With the center of dilation at the origin. So it's being expanded from the origin. There's other places it could be expanded from to create A prime, B prime, C prime. So what this means is A prime maps to A, B prime maps to B, and C prime maps to C. It's taking a shape on the coordinate grid. It's moving it somehow or making it bigger, and it's trying to make us sure that we know that A, B, C versus A prime, B prime, B prime, they're respective. So when we talk about C prime, we're talking about the new location where C would be. When we're talking about A prime, we're talking about the new location where A would be. Okay? So it says, what are the coordinates of the vertices of this? So it's basically asking where the points are. So what we need to do is look for that. So this is 2, 2. Okay, A is 2, 2. So if we were to double that, a scale factor of 2, we would get 4, 4. Okay, let me bring this down because you guys can't see that. We would get 4, 4. Okay. B is 4, 4, so it would end up being 8, 8. Okay, and C is minus 4, 2, so it would end up being minus 8, 2. So what we need to look for is an answer choice that includes the set in that right order. If it starts from C, if it goes CBA or BCA or BAC, it has to be in the same order that they gave us the original points from. Okay, so we should be getting 4, 4, 8, 8, minus 8, 4. Okay, and that turns out to be D. All right. So this one isn't really that hard. And they could have made it harder by not putting this at the origin. It would have been not as smooth for that. Okay. All right. So I'm going to do one more session with one last point, one last question in it. We're about an hour here anyway. I might do that right after this, take a 5-minute break and do the last question that way. Or I might do it tomorrow. I might do it later today. I might even do it tonight. Because that last question, let me try to find it just so it's on the screen. I think it was one of the last ones on the side over here. Let me see here. In the meantime, hopefully you guys enjoyed this series. If you guys have questions, feel free to email me about them. Yeah, it was this number question here. It's gone past. Come back. My machine is trying to keep up with the stream, and it's freaking out. All right, so if anybody wants to try to solve that by themselves, and there's a whole bunch of solutions to it, which is why I held this one for last. There's a whole bunch of ways to solve this, probably 5 or 6 ways, and I'll show you guys maybe 3 of them. All right, and I'm not going to give a hint yet. All right, so that's the answer choices if you want to catch it, and that is the actual question. All right, again, I'm Greg from GregsTutoringNYC, and you can email me at GregsTutoringNYC@gmail.com. All right, guys, and please subscribe because I have more coming, including SHSAT examples. Right, I'm going to go over the. I think I'm going to go over the current handbook from cover to cover. So yeah, all right, everybody, take it easy and have a great day.